are still going to be solving systems of equations today, but I want to look at word problems. So we did word problems at the beginning of the semester, but we did a lot of more complicated ones that involve tables and things. The problems I'm showing you today we could do with those strategies that we had before, but these are also ones where we could use systems of equations to help solve them. So for example, in the 2006 Winter Olympics, the total number of medals won by Germany and the United States was 54. Germany won 4 more medals than the US. How many were won in each country? All right. First thing, if you are going to have variables, you have to tell me what your variables are. I don't just want to see an X and a Y in there. So what are the two things we're trying to find?
The amount of medals won by each country.
Okay, so X could be
US medals.
The number of US medals. And then Y would be the number of Germany medals. So even if you don't do anything else, you get automatic points just for defining your variables. All right, now I need equations. If I have 2 variables, I need 2 equations. Okay, if you had 3 variables, you would have to have 3 equations to be able to solve it. I know that the total number won was 54, so what would my equation be? And then I know Germany won 4 more than the US.
X plus 4 is Y.
4 more than the US, that's X plus 4, is the number Germany won. All right, substitution or elimination, which would be easier?
Substitution.
Let's just take that substitute second equation and sub it into the first one. So add like terms. Subtract our 4. Divide by 2 and x is 25. Then I know y is x plus 4, which is 29. Right, am I done?
Yeah.
So if it's a word problem, how am I going to want you to answer? Sentence, okay. So Germany won 29 medals. And the US won 25. Questions there? So at the beginning of the semester, we did a lot of mixture problems. We talked about some interesting things. I want to do some of those same examples that I did back then using this strategy. So Sarah has $70,000 to invest and requires an overall rate of return of 9%. She can invest in a safe government-insured certificate of deposit, but it only pays 8%. To obtain 9%, she agrees to invest some of her money in non-insured corporate bonds paying 12%. How much should be placed in each investment to achieve her goal? There's a lot of numbers here. Let's start with the basic, identifying our variables. What am I trying to find?
How much she should place in each investment.
So she's going to do some in 8% and some at 12%. So I'm just going to say the X would be my amount at 8%, and Y would be the amount at 12%. Okay, I have 2 variables, so I have to come up with 2 equations. If I look back at the problem, she has $70,000. So what could I do for that equation?
X plus Y.
think about the interest. X is the amount at 8%. If it's earning 8%, how would I find the interest? Okay. Think about interest. We've found that many times. Interest is just principal times rate times time, right? I'm not making any mention of time. We're just assuming 1 year. So we just need to do our principal times our rate. So 8% is 0.08. And the amount I'm investing in that one is X. Plus the interest from the second investment. What would that one say? Overall, my interest, we are getting 9% of my 70,000. So that would be 0.09 times my 70,000. Okay. So we need to clean it up a bit, but here are the starting equations. What strategy do you guys want to do? Substitution or elimination? Doesn't matter to me. We did substitution on the last one. Let's do elimination. So if I want to eliminate my X, what would I take the first one times? Negative 0.08. So it gives me negative 0.08X minus 0.08Y. Negative 0.08 times 70,000. Negative 5,600. The second equation, we're not changing it, but I am just going to rewrite it. And I'm going to go ahead and multiply the 0.09 times 70,000. That's 6,300. So then if I add, my x's cancel. Negative 0.08 and positive 0.12 is 0.04. Equals 700. Uh, 17,500. You guys checking my math? Can't trust me. Okay. So to get my x, I just have to plug that in. I'll just plug it into the first one. So x is 52,500. So if we answer in a sentence, he needs, x was the amount of 12%, so $52,500. At 12%.
Why is
8%, thank you. Questions on that? These interest ones require a little more thought initially, but once you get used to them, they're all pretty much the same. It's just you take your interest rate times your principal and add those things together. So I'd like to try another one like that before I do anything else. Amanda won $200,000 in a state lottery. She first paid income tax of 30% on the winnings. Of the rest, she invested some at 1.5% and some at 4%, earning $4,350 interest per year. How much did she invest at each rate? I'm not sure why there's all these extra question marks in there. Just ignore that. All right. What do I do?
I think we're setting your variable.
So what's X?
Or some amount of 1.5 and then we have one for 30.
Okay, let's talk about that. So this one does have an extra percent in there. It's talking about this 30%. But what is that? It's income tax. So she got $200,000. That's what she won. But is that what she received in the mail when they sent her a check? No. So what we're going to do is take that off at the very beginning before we figure out how much money she invested. So how would I do that to figure out the actual amount she received?
Multiply and then subtract 200,000 by your answer.
Okay. So to find our tax, 200,000 times 0.3. And that gives us 60,000. So she actually had to pay $60,000 in taxes. So how much did she get to invest? 140,000. So that's our first equation. The x plus y is 140,000. Second equation is my interest. So x was at 1.5%, so I would do, and y is 4%. And how much interest did she get? All right. Substitution or elimination? What do you want to do? Elimination? Okay. Let's eliminate what? Preference? All right, let's eliminate y. I'll take the first one times negative 0.04. All right, and then what do we do? Once you set that up, you're ready to eliminate. You just add them together. So I get a negative 0.025x equals a negative 1,250. So if you divide by the 0.025, x is 50,000. So to find my y, I just plug that back in. Drag that over, and my y is 90,000. I'd like to do at least one more word problem. The next two are very similar, so we'll work one of them, and if we need the second one, we'll do it. So the manager of Starbucks decides to experiment with a new blend of coffee. She's going to mix some B grade coffee that costs $5 per pound with 40 pounds of A grade coffee that sells for $10 per pound to get the new blend. The selling price of the new blend is to be $7 per pound, and there is no difference in revenue from selling the new blend versus selling the other types. So she's making the same amount of money. She's not charging more for it, it's just how much it costs her to make it. How many pounds of the B grade coffee were required? Okay. So we really have three things here. We are going to mix coffee A and coffee B to get coffee C, right? I am trying to find how many pounds of the B grade coffee. So we can do X and Y if you want. So X would be the pounds of the pounds of the B coffee. Do I need a variable for the pounds of type A coffee? No, because I told you that. What's the other thing I don't know then? Yeah, so Y could be the pounds of C coffee, or the final mix. Now you can define these variables differently. You could use B and C if you wanted instead of X and Y. So it doesn't matter at all, you just have to define it. Okay, so I know that I'm mixing coffee A with coffee B to get coffee C. How much of coffee A am I putting in there? Plus, the amount of coffee B is X, and the amount of the final mix is Y. So 40 plus X is equal to Y. Okay, the other thing we know is the price. So coffee A costs how much? $10. And we put in 40 pounds of that. So you would have to do 10 times 40 to get the cost of that one. Okay, coffee B costs how much? And we have X pounds of that. And the final mix is how much? 7 pounds of the final mix. All right, I have my equations. So are we ready? Substitution would probably be the easiest. 10 times 40 is 400 plus 5x equals 7 times the 40 plus x. X is 60. And so that means Y is 40 plus 60, which is 100. But make sure the sentence should answer the question, and the question was only how many pounds of the B grade coffee. We need 60 pounds of that one. Okay. I know word problems are nobody's favorite. How are we doing with these? Find your variables, write your equations, and then solve like we were doing yesterday. I would like to look at the last two. So if you flip over your notes here, these are not word problems, but it's solving a system with 3 equations. And so I wanted to look at a couple of those, and then I am done, and then I'm going to give you guys time to work on homework. So if I am looking at an equation with 3 variables, essentially we're still going to do substitution and elimination. There are different approaches that you can take, but typically what I do in the easiest option is to take 2 equations at a time and eliminate a variable. Okay, it's not going to matter what we eliminate, but I just pick 2 equations. Let's just go with first and second. What variable do you want me to eliminate? Z. Okay, so to do that, we would have to take the top equation times 2. So I would have 2x plus 2y minus 2z equals -2. And I'm putting that with the second equation. So when I add those together, I get 6x minus y equals 14. Now, we're going to leave that for a second. We're going to go back to the original. I need to use the third equation because I haven't used it yet. I have to pair it with one of the first 2, and I have to eliminate the same variable. So I need to eliminate z again. If I want to eliminate z, which equation do you want to put it with? The top one? So to eliminate z this time, what will I multiply by? -3 on top. So that gives me -3x minus 3y plus 3z equals 3. And we didn't change the bottom equation. So when I put these together, I get -x minus 5y equals 8. So look at where we're at. What do you notice about these? They both have x and y in them. So we could use those 2 equations to eliminate something. What do you want to eliminate? X. So how would I do that? Second one times 6. So the first one didn't change. And we get y is -2. Once you get here, you figure out one variable, then it's just a matter of substituting back in to get the other. So if I have my y, I can plug that back in to get my x. So 6x minus -2 equals 14. So that means 6x is equal to 12, and so x is 2. Now you have x and y, so you can go to one of the originals and plug those in to get z. So maybe I went with the first one. X is 2, y is -2, so I get -z equals -1, so z is 1. Final answer. We put them as an ordered triplet, just alphabetical order, so x, y, z. So that's 2, -2, 1. So adding that third equation definitely creates a lot more work. And you can imagine if we were to go 4 or 5 equations, then it would get very, very time consuming to solve. So as far as solving systems like this, I will only go up to 3 systems at a time. Okay. I would like to really quickly just talk about the last example. It's not going to take us very long, and then I'm done. Sorry, I know I'm talking longer than I wanted to here. If you look at this one, what do you notice? Yeah, the bottom one doesn't have a Z in it. So what I would do is take the other 2 and eliminate Z. That'll be a huge time saver. And I'm not even going to have to do any work to do that. So you get 3x plus 2y equals 3. So now I can put my third equation with this one. If I want to eliminate y, what do I need to do? Okay. Let's take this times -1. When you add those together, what happens? What does that tell me? So, I have posted a handout on Classroom. It is 5 questions. 3 word problems, basically like the types we've done.